Hello friends, my name is Ramasu. Today we shall discuss about a topic that what is compiler. Friend, today's topic is very interesting, especially if you have interest in technology and you want to learn about it. So let's start, friend. First of all, I would request to please subscribe to my YouTube channel and click on the bell option as well so that my videos can reach to you, and also you can follow me on the Facebook page as well. So friend, compiler. Compiler is basically a software program which basically translates the high level language into a low level language. If you just see this diagram here, high level language means like Java, C++. So whatever the source code you will write in the high level language like Java, C++, etc., and compiler will compile the code, source code. Compilation means that if there is any error, it will tell you that if there is any error in the compilation. If the compiler successfully run the source code of the high level language, then it will convert it into a low level language. Low level language means machine language code or zeros and ones. The simple example is that the low level language means that the hardware can understand the zeros and ones. So basically the compiler is basically a software program which takes the input, the source code of any popular languages, like any language, any high level language like Java, C++, C, etc. So all these high level languages, and compile it, and after compilation, if there is any error in the compilation, it will tell you, and after compilation it will convert into a low level language or machine level language. So this is the main purpose of the compiler. Now here's the question that how the compiler actually works. Friend, first work or task of the compiler is the lexical analysis. Lexical analysis means the compiler basically split the source code into lexemes, which basically individual code fragments that represent specific patterns in the code. So basically based on the pattern, it will tokenize the syntax and semantics. Then syntax analysis. Syntax analysis means the code syntax, it will be checked that it is correct based on the rules and the regulations, rules and the source code. This process is also referred to as parsing as well. After that, the semantic analysis. Semantic analysis means in which compiler verifies the validity of the code's logic. This step goes beyond syntax analysis by validating code's accuracy. For example, the semantic analysis might check whether variables have been assigned the right types or have been properly declared or not. If the variables are not properly declared, it will give you a semantic error. Then the IR code generation. That means after the code passes through the all the previous three steps or phases, the compiler generates an intermediate representation or IR of the source code. The IR code makes it easier to translate the source code into a different format. However, it must be accurately represent the source code in every respect without omitting any functionality. Then optimization. The compiler optimizes the IR code, the intermediate representation of source code, in preparation for the final code generation. This type and extent of optimization depend on the compiler. Okay, then output code generation. The compiler generates the final output code using the optimized IR code. So these are the basically 6 steps in which the compiler generates the machine code. Okay, then there are mainly 3 types of compiler. First one is the single pass compiler. Single pass compiler means that when all the passes or phases of the compiler are present inside a single module, it's simply called a single pass compiler. It performs the work of converting source code to the machine code. So that means the 6 phases which we have already discussed in the previous slides. So in single pass, compiler goes through all these phases. Then the two pass compiler. Two pass compiler means that it is a compiler in which the program is translated twice, once from the front end and the back end from the back end known as two-pass compiler. In this base phases there are two passes. Then multi-pass compiler, when several intermediate codes are created in a program and a syntax tree is processed many times, it is called multi-pass compiler. It breaks code into smaller programs. Now we can talk about the advantages of the compiler, because if you can understand the basic purpose of a compiler, that it basically converting the source high level source code into a machine language code. Now the main advantage of the compiler is basically the efficiency. Efficiency means that compiled programs are generally more efficient than interpreted programs, because the machine code produced by the compiler is optimized for the specific hardware platform in which all will run. So that means basically, obviously friend, if the program which is obviously converted into machine language, so hardware can easily understand it, easily process it. And portability, once a program is compiled, the resulting machine code can be run on any computer or device that has the appropriation hardware and operating systems, making it highly portable. Then error checking. Error checking means compiler perform comprehensive error checking during the compilation process, which can help catch syntax, semantics and logical error in the code before it is running. So that means if there is any error in the source code, like for example you missed to, like you have opened a curly bracket and then missed or forgot to close the curly bracket, so obviously it will give you an error. Optimization is another advantage. That means compiler can make various optimizations to the generated machine code, such as eliminating redundant instructions or rearranging code for better performance. So optimization is also a very big advantage of compiler. Now we can talk about disadvantages of compiler. First one is the longer development time. That means developing a compiler is a complex and time consuming process that requires a deep understanding of both the programming language and the target hardware platform. So basically friend, making a compiler is a very long taking development time, because it's not easy, because you must have knowledge about programming language, you must have knowledge about hardware as well. Then basically because there are two ends, okay, so programming language and the hardware, because the programming language converted into a machine language which hardware can understand. So making a compiler is also a very tough job and very time consuming job. Then debugging difficulties. Debugging compiled code can be more difficult than debugging interpreted code, because the generated machine code may not be easy to read and understand as well. Then lack of interactivity. Compiled programs are typically less interactive than interpreted programs, because they must be compiled before they can be run, which can slow down the development and testing process. Then platform specific code. That means if the compiler is designed to generate machine code for a specific hardware platform, the resulting code may not be portable to other platforms. For example, the compiler is running for ABC hardware, so it is not possible that the some machine code can run on any other platform. So platform specification is there, so it is also a very difficult scenario, because for every specific hardware you have to make the specific compiler as well, because the machine code will not run on any other hardware. So this is also a very big challenge here. So friend, thanks a lot for watching the video. I hope you like this video. If you like it, please share it with the friends and colleagues, and thanks a lot for watching the video.